Okay, today we are going to use our knowledge of parent functions like that. Like I hope without graphing it on Desmos, you could have known that that kind of looked like this. Raise your hand if you knew that. Okay, good. We're going to use our knowledge of parent functions to start exploring what happens if we transform this parent function by doing a couple things like maybe I put a x plus 3 on the inside and then plus 8. Where do you think that would go? Right now, I'd like you to make a prediction by making your sketch and saying, I think it's going to be like this over here. Go ahead, make your prediction about where it's going to be on the right side of your screen or left. I don't care which side your Notability is on. But on Notability, sketch what you think it probably will look like. And then we'll actually use Notability and graph that and see if you're right. All right, go ahead. Take your guess on where you think it's going to be. By the way, mine is totally wrong. Okay, but take a guess where you think the U shape should be. And now hit graph on Desmos. Go over there, type it in, hit enter, see what it actually looks like. See if your prediction is pretty accurate or not. And if it goes the other way than you would think, learn from that. I'm going to pause for a second while you try this one. Okay, I had to kind of zoom out to see what it looked like. By the way, if you ever get zoomed really far in or really far out, it really messes up Desmos. So I looked up a few ways, asked some kids who are good at this, what if your scale gets way off because you zoomed way in or you zoomed way out? Teachers have the same problem, by the way. Like we're trying to find something on a graph, we zoom way in, and then all of a sudden the numbers scales are all messed up. Like the x-axis is counting by 2s, and the y-axis is counting by like 20s. And then it skews how the thing looks. Everybody hit the wrench once. In Schoology, you hit the wrench. Find the wrench. Yeah, sorry, Desmos. Sorry, Desmos. In Desmos, find the wrench. Do you see anything underneath the wrench that might allow you to reset your scale so that it's not skewed anymore? How about the words zoom square? If you hit zoom square, that will make sure that you are counting by the same thing on X and Y. See that where it says zoom square? Okay, if you hit the wrench, and underneath the wrench, there's a little box that pops up. Look for the word zoom square, Z-O-O-M-S-Q-U-A-R-E. It's there. All right. One more thing. If that doesn't work for you, a tip, you know what the hamburger button is? On my screen here, you see the hamburger button? You see why some people call it the hamburger button? Kind of looks like 3 hamburger patties, like a triple. All right, anyway, that's a name for that button. Otherwise, what else are you going to call it? So, all right, so the hamburger button. Underneath there, you can always just make a new graph. If you just type in a new number here, the scale will still stay messed up. But if you go underneath the hamburger button there and say, add new graph, it'll start over with nice axes again. Okay, so if you ever get zoomed in too far, those are 2 things you can do. Yes? Where's the little house? Oh, okay. But I don't know if that rescales it. You know what I mean? It brings you back to 0, 0. Oh, it does rescale it. I didn't know that. That's a 3rd way. Awesome. Okay. Well, I hope you noticed from this that my parabola went to the left and up. Which part of this was going to the left? Yes? The plus 3. And that part is going up and down. Okay, so I have a way to remember this, and this is a way that doesn't just work for this problem, works for all of these functions. Every function has this. There's the inside of the function and the outside of the function. And the stuff on the inside is horizontal on the inside, hence high. And the stuff on the outside of the function, like this, see, it's not in there with the x. The stuff on the outside is vo. How many guys have seen the Seven Dwarfs? They sing hi ho, it's off to work we go. Well, this is hi vo. Hi vo. If you think the server has lost his mind, it's a Disney cartoon from way before you were born, but it's got these 7 little dwarfs and Snow White's with them, and anyway. So, hi vo. Telling you, it's a really handy little saying. So if I make a new one and it looks like this, y equals negative absolute value x plus 3 minus 7. Don't type that into, I keep wanting to say Schoology, Desmos. Don't type that into Desmos. But I want you to use hi vo and see if you understand what I'm talking about. Horizontal on inside, that's a horizontal move. And I also told you, don't trust the things on the inside. Do you remember the prison story? All right, they're on the inside. That's what they call it too. My friend tells it, when you're on the inside. That's prison talk for you're in prison. Okay, so anyway, when you're on the inside, don't trust the inside. Okay, but you can trust the outside. So that minus 7, which is a vo, vertical on the outside, that moves it vertically in the direction that it seems like it moves it. So do you get negative 7 is actually down 7, just like you would expect? And this one, which should seem to you like it moves to the right 3, actually moves to the left 3. And then lastly, this is a new one we haven't done yet. What's this negative in front do? Well, first of all, is it on the inside or the outside? Outside. So it's a vertical thing. What do you think a negative on the vertical is going to do? Well, there's only 2 choices. Either it's going to go down vertically, or, yes, it's going to flip. You are correct. Could you get the door for us? It's getting really loud. Thank you very much. So it's going to flip. So then stop. I want you to try to sketch what you think this graph looks like. Hint, it's not a parabola. Remember, we're not using a parabola here. There's no x squared in this thing. Do you remember what shape that parent function is? And then it moves 3 to the left and down 7 and is flipped. Sketch what you think it should look like first. Do not type it into Desmos yet. Sketch it. And you let hi vo be your guide to what's happening. Horizontal, inside. Vertical, outside. Hi vo. This topic is one of the top 5 for all year. You're going to be here for 9 months. And I'm not going to say that very often. This topic right here is one of the top 5 most important ones. It's about moving functions around. We spend a fair amount of time on it. You got to get good at it. And we're going to use it a lot in pre-calc. You got to be able to just look at that and go, oh yeah, I know what that function's doing. Even with new functions that you get taught, you're going to be like, okay, inside, oh, that's a horizontal thing on the inside. So anyway, this is really important. I didn't say it was the most important. I'm saving that one. But it's in the top 5. Okay. Shouldn't erase that. Now I don't know how to get it back. Y equals, I think there was a negative. I know there was an absolute value. What was in there? And then? All right. Here's what you should have thought. Absolute value. I know that, Mr. Server. It's the V shape. How many of you knew that? Okay, next. I know it's been moved 3 to the left because it seems like it's to the right, so it's to the left. Then I know it's also been moved down 7. Now here's the weird part. Flipping it across the, which way? Well, it's a vertical on the outside. This negative is part of vo, right? Vertical on the outside. It's a vertical flip. How do I flip that? Well, hint. I would have flipped it when it was right here. Do you get how that would be easy to flip vertically? Then, if I flip it vertically, and then I move it down 7, it'll be a lot easier to see what to do. There. Oh, that's down 6. There's down 7. That's my prediction for what it should look like. Now go ahead, type it in to Desmos. Let's see if that's what happens. I'm willing to admit I'm wrong sometimes, because sometimes I do it in the wrong order. We're not going to focus too much today on what exact order you should do things in. That's a thing, just like in math, we have order of operations, but it's not quite that simple. The order you do these in is important, and it'll be a test question on the order, but I can't teach you that all in one day. What I can teach you is a lot about what happens if I put it on the inside. What happens if I put it on the outside? And there's one thing I never taught you yesterday. Who noticed a question in the homework that I never covered? And that's going to happen from time to time. Yes, the circle. Now, kids react to that in different ways, and I'm okay with any of these reactions. One reaction is, I can't do this. He didn't teach us this. That's true. But did anybody go further than that and just not say, okay, well, he didn't teach us that, so I can't possibly get this answer right? What did you do? You looked it up. Where? Google. Google is a thing. You can use that at home. And it helps because now he knows the circle thing and nobody else does. Oh, maybe somebody. What do you do?
I sort of given up on that question.
Mm-hmm.
The next question after that, I saw that they had the equations for all different,
nice.
equations. I saw that it had a circle, and so I just figured out there.
Awesome. And then another kid in a different hour mentioned that. Another question in the questions listed the equation for a circle, which then allowed him to go back and fix that one before he hit submit. Awesome. That's a good method. So Google, how do you find the equation of a circle? It might just pop right up on the screen, or it might be videos on YouTube. All right. So I'm not saying you have to do that, but I just want you to realize that you have more ways to learn than just me. Who else? You have a different way? Yes, that came up in a different class. Ask somebody who's already had this class before. Ask somebody who knows the equation of a circle. Okay, like somebody older than you or in a higher math class than you. All right. Last one that somebody brought up from a different hour, and I don't know if anybody in the hour used this, but they looked at the completed notes. Did you know that sometimes there are completed notes posted? I'm not going to promise that every time that there are. And that means you could go to a question about, and you could look up, oh, here's one on circles, and here's the teacher wrote the equation for a circle right there in the completed notes. So you have lots of resources. I'm just reminding you what's there. Okay. Now, I think you're getting the idea of how you could use Desmos to graph anything. You just type it in, boom, it's done. Bad news is Desmos is not allowed on your next test. I'm using Desmos to just get you the idea of where the function should be. And then Desmos can give you a quick, yeah, it's over there. You know what I mean? All right. Now here's one that's kind of tricky. Try this one. Y equals negative parentheses x plus 2 parentheses squared. Okay, now that one's not that tricky, but what happens in a minute will be. Start with, just do that one. Don't type it in. Figure out, what should that look like? Oh yeah, I know that shape. And then I know it's moved this way. And then I know it's flipped that way. Sketch what you think it should look like on your notability side. Sketch where you think it should be. And then type it into Desmos and find out if you're right. All right, using high-vo language, is that vertical or horizontal? Horizontal. Horizontal, and it seems like to the right, so it's actually to the left, too. And then this, horizontal or vertical? Vertical, because it's on the outside, if it's a vo. Okay? So that's a vertical. The official word is not flip. Does anybody know the official word? Reflection. Very good. It's a vertical reflection. All right. Now, if this was like this, and then it went 2 to the left, and then it gets reflected vertically. How many of you predicted and were correct that it was there? Okay, awesome. Now, here's the thing I think you're going to think is weird. What if I put, now don't type it into Desmos, I want you to predict first. What if I put a negative there? Did I just subtract the x? No. Did you get effectively, I just multiplied the x by -1? And was it on the inside or the outside? So it has something to do with horizontal. Make your prediction about where this thing's going to go, what it's going to do, and then go ahead and try it. Use Desmos, find out what happens. Did it move over there? Now, what in the heck happened? Yes.
So the negative on the outside flips over the y-axis.
Uh-huh.
The outside.
Yep. All right. So, think is one way to think of it, which is the flip over the axis, which is like this. Do you get, if this thing flips across the axis, it's going to flip over there, and the stuff that was on that side of the line goes on this side of the line. You know what I mean? These two cross. Here, I'll make this green. And you see how it's a reflection over that axis? All right. Here's another way to think of it. By throwing in a -1 here, isn't it sort of like saying the opposite of what I did before? I moved to the left 2, but now I'm doing -1 means opposite of that, and it ends up going right 2. That's another way to think of it, but it's okay if you don't think of it that way. I like the idea of that's a reflection across the other axis. That negative there makes it flip over there. All right, now what if you are just stumped on a test and you don't have Desmos to check it? And you're like, I don't know where this graph is. I think it's over there, but I'm not sure. What's your best friend in graphing? XY chart. I told you before, it can tell you where any graph is. All right, so let's use the XY chart to find out where this one is. I know we know because we already saw it, but XY, let's find a few points. How many do you have to have on your tests? 5. 5 points on any graph. You can't just graph 3 things and go, oh, I see the curve, draw the line through it. Nope, I have to take off partial credit at least. 5 points. Now, if you kind of know where you think it is, you could be more strategic. Let me show you what I mean. Do you get how I think we figured out it's kind of over here? Do you get that means that x values of like -5 would be a bad idea because it isn't over here? You know what I mean? So at least it narrows down what you should stick in. Now, as I look at that, I'm thinking, okay, I could stick in like x equals, what do you think would be really nice and easy? 2. 2 is a good one. Now, there's others, but let's say I put in 2. If I put a 2 in, everybody right now, figure out what the answer comes out to. You have to fight tiredness. I know. We're at the end of the day. Your English teacher made you do stuff. Your science teacher made you do stuff. Social studies teacher made you do stuff. Might have even had a gym. Well, I don't know. Does anybody even do gym, like normal gym class? I guess there is still some people. How many guys took the gym class the way with the Fitbit thing? All right. How many you haven't had a gym component yet? All right. So, anyway. So how do they get it on the Fitbit thing? How do they keep you from like putting a Fitbit on the dog? How? How do they change it?
Film videos of you after an exercise activity where it looks like the actual performance.
Ah.
Just explain what you did and how it correlates to what you're learning about.
Okay. All right. Because you guys get that they just used to take the Fitbit data, and then like people were like doing crazy things with the Fitbits to like make it look like they were exercising, but put it on the dog, put it on the fan. Okay. Yes. Put it in the dryer. Okay. I wish they could like track the dots, you know what I mean? Like and make a graph of them and they could be like, yeah, you worked out by going in a circle like really fast. I don't think so. Anyway. Okay. So you stuck in it too. Were you smart enough to get 0? Is that what you got? All right. Does that actually bear out on our not Schoology, was it Desmos? On our Desmos graph, was there a dot right there? Yeah, there was. All right, I was just kind of estimating when I slapped this up here, but yeah, it goes through there. Okay, awesome. Now you're supposed to have 5 points. Are you going to have the same 5 points as a kid next to you? Well, sometimes, because there's 5 probably easiest numbers. The numbers that are around 2, like what? 3, 4. You could go backwards and say maybe 1, maybe 0. Could you go to -1? Sure, you could do that. Could you go to like 18? Well, it's going to be difficult to graph because once you stick in 18, you're going to get a huge negative number and it won't probably go on your graph. So that's not real smart. All right. So which 5? I don't care. But when I'm grading it, I'm going to look for 5 distinct dots. And a kid who's got something like this where they get a little lazy, you stick in 3, and they go -3 plus 2 is -1 squared, which is 1, and then it makes it -1. -1, 3 -1, over 3, down 1. A kid who just graphs like 3 things like this, and then they stop, I notice, I mark off, at a minimum 5% off their test grade. Okay, that's a lot to lose. So if you had a 95 going, now you're down to a 90. You know what I mean? So just have 5 dots. There's only one exception to that. There's one weird parent graph that's very difficult to get 5 dots on. And that one I'll give you a break on. You won't have to get 5 dots on that one because it's too hard to. So I'm curious which function it is that's difficult to get 5 good dots on. It's the 1/x function. Would you please sketch from memory what you think 1/x looks like? It's one of the parent graphs a lot of people don't remember. This is on your side of your device, I should say, because not everybody in here is using an iPad. That's got Notability or some similar competing product. All right. If you sketch this properly, it should have been something like this. It's a sketch, so it's not a graph. Do you get the difference? A graph has to have distinct dots. This is just a sketch. Raise your hand if you had yours sketched approximately correctly. Okay, and if you didn't know this one, memorize it. It's a big deal. Now, do you get that this one has a few easy points, but not many? Let's put in some numbers. What's your best friend in graphing? XY chart. And you go, and it's not Desmos, by the way. Your best friend in graphing might be Desmos when you're home, but not on the test. Okay, so if I put in 1, does that work? Nice. 1/1 is 1, so 1, 1. Put a dot right there. I know it's going to be a spot there. And then how about 2? Well, it's not too bad. If I put in a 2, what is it? 2, 1/2. Some people are like, well, I can't graph that. Sure you can. I'm not going to be that picky if you found exactly where a half is. 2, a half's about there. Okay? Now, what if I wanted whole numbers, though? Or integers, which are like whole numbers except including negative numbers. That's what an integer means. Okay, now, what would an integer be? One more integer. 1, 1 worked. What else? -1 goes with 1 or -1. -1. I'm going to put in -1 and I see that I get -1. -1, -1 is right there. And again, all the rest of them won't be integers. Do you get how it'd be a pain in the butt to have to make 5 of those? Okay, so on this kind, all I need is those 2 key points. I don't even need one of the ones that have fractions. I need the 2 key points that are integers. And then you also have to have the asymptotes on this graph to get credit. And this is important. I got asked this a lot the other day. I'm going to remind you. That line running across that's right on the x-axis, do you get how it's very tempting to think that's x equals something, but it's not? What is it? Y equals 0. Okay, good. Then how about the x one? Well, this is the y-axis, and so it's tempting to think it's y equals 0, but it's actually x equals 0. Okay? So as long as you have the asymptotes labeled, then I'm okay with only 2 points on this graph. Because those are the only points that are exact lattice points, those are called. The spot where it's like right where the 2 lines cross on a graph, not in between, those are called lattice points. I'm okay with you having only these 2, and then as long as you have the asymptotes in there, you'll have to connect it with a line that's kind of like mine, that's kind of close, you know. Gets closer to the asymptotes and never touches them. Try not to touch the asymptotes. It's like an electric fence. All right. Then let's see if you have learned enough that you can predict where this graph is going to be. Y equals -1 times 1 over x. Make a sketch of where you think that will be. Sketch it. Don't actually graph it yet. 12-minute warning. Time to wrap it up. If it seems shorter than usual today, it's because it was. Why? Mass day. Shortens up the hours. Okay. What if you were lost? You could always use a XY chart. It would work every time. So many people get the graphing test wrong and they don't have a little XY chart. I think what happens in their head is they're like, oh, I can't remember this one. And they think like, well, okay, I know I'm supposed to flip it, but I don't remember which one it is, so I can't do it. False. You could do it. Just make up one of these. And you stick in some numbers, like what would be a good number to stick in? And you get what? -1. That's different than last time, isn't it? 1 -1's down here. That's interesting. And then, what if I stick in like 2? Well, that's not going to work really well. What else could I stick in that would work really well? -1. If I stick in -1, I get +1. -1, +1 is right there. And hopefully some of you noticed that when you flip this thing, it used to be here and here, but it flips so that it's now here and here. This is a weird one. Do you get that that is a reflection? And it's technically on the outside, which makes it a which way reflection? Is it a high or is it a low? It's horizontal on the inside? I don't think so. It's on the outside, so it's a it's a vertical. But I know some of you are like, but wait a minute, it's a vertical reflection because see, the thing is right below the other thing. But it's also a horizontal reflection because the thing is exactly across from the other thing. This is the only one where a vertical reflection and a horizontal reflection are the exact same thing. Isn't that weird? It's the only function like that. Because if you put a negative down in the bottom and you do your little XY chart, you're going to get the exact same numbers. Therefore, it's the same. Okay. All right. So, what's your homework like? It is a worksheet, which has way too many questions on it, in my opinion. So, let's find that worksheet. We'll cut it down to size, and we'll give you some to practice. Okay, so here we are on the homework. Now, I'm cutting down the homework a lot because these take a lot of time. Not only do you have to make an XY chart, because remember, these are not sketches. You can't just go, oh, it's a parabola that's moved down 4, so it's like this. Okay, close, but you got to get me how many exact points? 5. And then you got to answer what the domain and range is of it. Well, it isn't that hard, but it's got a lot of parts on each one. Okay, so all I'm asking you to do is problems 1 through 5. I know that cuts out a tremendous amount of the worksheet. I'm aware there's other pages. All I'm asking you is for 1 through 5. But here's how this works. if you actually do the 1 through 5, you'll be okay. But if I cut the assignments down and then people still don't do them, then I got the worst of both worlds. So I need you to be mature about this. If I give you a doable assignment, you got to get it done. And then if you're struggling with stuff, you got to do extra ones. Like if you realize, okay, that wasn't enough problems for me because I got almost all of them wrong, you should do ones that I didn't assign. It's not like you can't do the others. Go do number 6 or number 7 if you had a lot of trouble with the other ones. That's how you do this the mature way. And it's kind of a win-win. You get a bite-sized assignment, doable assignment, but you have to be smart about when you kick in and do extra problems, only when you really need it. Okay, so what do I want to see on this one? An XY chart where you show me 5 points. So what's a good point to pick? 0, and 0 gives me -4. And, oh, it's on my graph, cool. Now I'm going to stick in another spot. 1. 1 squared is 1, -3, good. 1, -3 is pretty close to my graph, so I wasn't too far off yet. How about 2? 2 squared is 4, 0, 2, 0. Ooh, I was definitely off on that one. See what I mean? So my little quick sketch was not that awesome, so I better grab this, move it out of here, and now I'll start obeying my dots. And then maybe I'll do one more big one, like 3. 3 squared is 9, -4. 9 and -4 makes 5. And maybe I should do some on the left side. So like maybe -1. If I stick in -1 and I square it, -1 squared will be 1. 1 plus -4 is -3. -1, -3. Oh, that makes sense. It's starting to come back up again. And that means generally, here's my parabola. How many dots do I have? 1, 2, 3, 4, 5. I will get full credit for that one. Even if there's not symmetry, yes, as long as your 5 dots have gone around the corner. Here's what I mean. Let's say that this one ends up being a square root. Actually, this one is not a great example because if you had 5 dots in a row, they're going to curve. And that one, oftentimes, the square root one is another one where if they go off the graph, I can't expect you to have 5 dots anymore. On that one, you might only be able to get 3 that are on the graph. And after that, they go off the graph. Can't make you do those. Okay? So even if you can only fit 3 points on, then you'll only get 3 points. A lot of times in the square roots, you only get 3, maybe 4. My point is, though, if you get, let's say it's supposed to be a V shape, but the kid does 5 points that are all here, do you get that they're not going to get a very good V shape? Know what I mean? So you should really do some on either side of where it makes the turn. All these graphs have a turn on them, except y equals x. We don't almost ever graph that one because it's just too simple. That one doesn't have a turn in it, of course. But. Okay, just do 1 through 5. Make sure you show me 5 points that are distinct dots, and also answer the domain and range. I'll do this first one for you. The domain is all reals, so if I put a big R, that would actually be correct. Or -infinity, +infinity, like that. The range is how low does it go? -4. The bracket, because it touches at -4, comma, how high does it go? Forever, infinity. There's your domain and range reminder. All right, so just do the first 5 well, and I'm going to feel like you're in good shape for today. Okay, that's all I got for you for today.